Good morning, guys. We're going to continue with our notes today. This one's titled Notes 4.02, Solving Exponential Equations Using Logarithms. And so, to start off in our notes, we read, exponential equations are equations in which variables occur as exponents. When these exponents are rational, another word for rational is fractions. When these exponents are fractions, we must follow the steps outlined below. So these are just some steps that will help you solve these types of problems. And so, to organize ourselves, right? So if we follow these steps, we should get to the final answer and we should be able to solve the equation. So step one is isolate the exponential term in the equation. So we have to look at the equation and figure out which term is the exponential, okay? And to know what it looks like, we should know what an exponential term is. It's any term that has a base and a power. So I'm going to say b to the power of a. An example of an exponential term would be probably something like x to the power of. In this case, we're going to be using fractional exponents. So x to the power of, let's use 3/2. Okay. So we're going to be looking for exponential terms that look like this. And what do we want to do with them? We want to isolate them. Second step, we want to raise each side of the equation to the reciprocal of the rational exponent. Here's another term, reciprocal. Okay. So a reciprocal is defined in mathematics, it's a pair of numbers that when you multiply them, it equals to 1. Okay, so for example, let's use the 3/2 that I was talking about. So if I have 3/2 as my fraction, then the reciprocal of this, reciprocal is 2/3. Okay, so the reciprocal of 3/2 is 2/3. Because if I multiply these two pairs, it equals to 1. So we're going to be looking for the reciprocals of the fractional exponents. And we're going to raise both sides of the equation to the reciprocal of the rational exponent. And so you're going to see this as I work on the examples. And then step 3, solve the resulting equation. Okay, so let's look at the examples, and I'll leave the steps on the screen just so we can kind of see what's going on and follow step by step. So first step, let's see example 1. Solve each exponential equation, show all your work. Example 1, step 1, isolate the exponential term in the equation. So which term in this example is the exponential term? Which one looks like it has a base and a power? Correct, it's this one, right? It's x to the power of 1/2. X to the power of 1/2. So I want to isolate this term. Okay, so let me pick a color here. Changing my marker color here. But we want to isolate this term in particular. So we want to move everything else to the other side. So one way of doing that is, the opposite of adding 18, subtracting 18 on both sides. That gives us, correct, 36. Bring down the 3, bring down the x to the 1/2. And then in the next step, how do you get rid of the 3? Right? The opposite of multiplication is division. 36 divided by 3 is 12. X to the 1/2. Okay, so we've completed step 1. Step 2, raise each side of the equation to the reciprocal of the rational exponent. So this is the rational exponent. It's 1/2 is the fraction, right? What's the reciprocal of 1/2? Well, we just want to take this fraction and flip it. So what's 1/2 flipped? Correct, it's 2. So what I'm going to do is raise both sides of the equation to the power of 2. The power of 2. And what's going to happen is, on the right side, I get x, and 12 times 12 is 144. Awesome. All right, let's try another one. Example 2. Step 1, isolate the exponential term. Which term in this expression is the exponential term? Which term is the exponential term? And you should identify this one. So if I want to isolate it, I want to get it by itself. First of all, I want to get rid of the 1, right? So opposite of adding 1, subtracting 1. And so I'm going to bring down everything else. 16 minus 1 is 15. And then the opposite of multiplying by -3 is dividing by -3. Right? These become 1. And so we're left with 5k to the power of 1/3 equals -5. Okay. Step 2. Raise both sides of the equation to the power of the reciprocal. So if 1/3 is the fraction, what's the reciprocal of 1/3? Flip 1/3 over, and you should say that it's the power of 3. So we're going to raise both sides to the power of 3. So there's going to be, this is going to reduce to 1. So I end up with 5k. Oh, sorry, 5k, not x. 5k equals, what's -5 to the 3rd power? What's -5 times -5 times -5? -125. And then one more step, divide both sides by 5. So k equals -25. Oh, sorry about that. There we go. K equals -25. All right, let's go to example number 3. Example number 3. Now I'm going to zoom in so I can have a little bit of extra space, and you can see it kind of large on your screens. Okay, so step 1, isolate the variable. I'm going to add 12 on both sides. I'm going to end up with y to the power of 2/3. These are going to cancel. Equals 36. Step 2, raise both sides to the power of the reciprocal. And so what's the reciprocal of 2/3? What's 2/3 flipped? It's 3/2. Okay, so these are going to cancel. They're going to multiply, and so I'm left with y equals, and now what I want you to remember is, if you remember when we talked about rational exponents, when we had that test on exponents and we had fractional exponents, we got to go back and remember, how do we rewrite from exponential form to radical form. How do we rewrite from exponential form to radical form? And what we should remember is we're going to write it in the following way. We're going to say it's the square root of 36 raised to the power of 3. Because remember, there's a 2 here. And so what we want to remember is if we have a fractional exponent of 3 over 2, if we want to change this exponential form to radical form, it's going to be square root because the denominator is 2. And then it's going to be to the power of 3 because the numerator is 3. Okay, just trying to remind you guys about that. So, what is the square root of 36? Correct, it's 6, right? But what we got to remember is whenever we take the square root, it's going to be plus and minus. Plus and minus. It's the third power. Okay? And so we're actually going to get two answers here. We're going to get a positive one and a negative one, because we got to see what's going to happen when I raise positive 6 to the power of 3 and then negative 6 to the power of 3. So what is 6 times 6 times 6? Correct, that's going to be positive 216. And then what's negative 6 times negative 6 times negative 6? What's a negative times a negative times a negative? That's going to be a negative, and it's going to be 216. So I have two answers here. I have positive 216 is one answer, and negative 216 is my second answer. Okay? All right, let's go to the next one. All right, so it looks like in this case, this one's a little bit different, right? If you think about it, this term in parentheses is being raised to a power. So in a way, this is already my exponential term. So I don't need to isolate it. It's already by itself, right? It's already by itself on the right side. There's nothing adding to it. There's nothing multiplying in the front here. So I can move on to step 2. And so step 2 says raise both sides to the power of the exponent. But let me do one thing here. Let me just rewrite it again. So I'm just going to copy it just so I can have space. But I'm not going to change anything. I'm just going to rewrite it. And what we're going to do is we're going to say, okay, I'm going to raise both sides to the power of what's 2/3 flipped? It's 3/2, right? And so 2 over 2 will cancel, 3 over 3 will cancel. And then I'm going to rewrite 9 to the 3/2 in radical form. So that's going to be the square root of 9 to the power of 3 equals m minus 22. Okay, so before we add the 22, we got to simplify this part. So what's the square root of 9? That's 3. And what's 3 times 3? Oh, sorry. Square root of 9 is plus and minus 3. What's 3 times 3 times 3? It's positive 27. And then what's negative 3 times negative 3 times negative 3? It's negative 27. So I'm actually going to get two answers again. And that's because, again, just want to keep mentioning this, is if I square root a number, I'm going to always get two answers, a positive and a negative. Positive 3, negative 3. So what we're going to do is we're going to look at it in the following way. We're going to have, in one case, oh, sorry, no, we could do it this way. We could say, the opposite of subtracting 22 is adding 22. Okay, so we're going to add 22. So it's going to be 22 plus and minus 27. So what we got to do is we got to do two problems. We got to solve two things. We got to figure out what's 22 plus 27. What's 22 plus 27? Right? That's 49. 22 plus 47 is 49. That's one answer. Now let's do the subtraction. What's 22 minus 27? What's 22 minus 27? That's negative 5. So we get two answers here. We get positive 49 and negative 5. Okay? Positive 49 and negative 5. Let's go to example 5. Okay, so first step, isolate the exponential term. Get this term by itself. So we got to get rid of the 10. So subtract 10 on both sides. We end up getting v minus 25 to the power of 3/2 equals, these will cancel. What's 2 minus 10? It's negative 8. Then we got to raise both sides to the power of the reciprocal. What's 3/2 flipped? It's 2/3, right? So we're going to get a cancellation here and here. So we get v minus 25 equals, change exponential to radical form. So this one's a little bit different because notice, what's the denominator? It's 3 now. So it's going to be a cube root. Cube root of negative 8 squared. Cube root of negative 8 squared. Okay, so I'm going to copy the left side. And what is the cube root of negative 8? What's the cube root of negative 8? What number raised to the power of 3 will give me negative 8? And that number is negative 2. So the cube root of negative 8 is negative 2. Copy the square. And so let's go in the next step. Copy the v minus 25. What's negative 2 squared? That's 4. And then add 25 on both sides. Let me erase this part here. Add 25 on both sides. We get v equals 29. And I know what you're thinking, right? You're asking yourself, but how come in this step we don't get a positive and a negative 2? Well, remember again, for square rooting, that's when we get a positive and a negative answer. But for cube roots, since we're multiplying by a third term, then we know for sure that if the term inside the cube root is negative, then our answer is going to be negative. If the term inside the cube root is positive, then our answer is going to be positive. So that's the difference here. And then, of course, negative times a negative becomes a positive because we're going to square it, so we get a positive 4. So in this case, we get one answer. All right. Next example. This one actually looks like similar to example 4, one we did a little while ago. And so here we have, we already have the exponential term by itself. So what we can do is we can raise both sides of the equation by the reciprocal. So 3/2 flipped is 2/3. So this will cancel and this will cancel. And so that's going to leave me with 4n minus 13 equals, now let's change this exponential into radical form. Let's change the exponential into radical form. So it's going to be the cube root of 27 squared. Cube root of 27 squared. And so let me copy the left side because I want to simplify the right side first. I want to simplify this expression. So what is the cube root of 27? What number multiplied 3 times by itself will give me 27? What number multiplied 3 times by itself will give me 27? And isn't 3 times 3 times 3 27? Yeah, so the cube root of 27 is 3, and we're going to square it. Let me write that a little bit smaller. We're going to square it. Okay. So I'm going to copy the left side, and what's 3 squared? That's 9. Then a little bit of algebra. Add 13. We get 4n equals 22. And then divide both sides by 4. So n equals 22 over 4. Can we reduce it? Are they both divisible by? Yes, they're both divisible by 2. So 22 divided by 2 is 11. And 4 divided by 2 is 2. So 11 over 2. All right. So again, feel free to pause the video, and if you want to just pause it here and look at the notes and maybe copying it on your own or looking it over on your own. All right, the next thing we want to talk about, and then we're done, is what do we do if we have exponentials with different bases? And so if we remember from the last notes, we were dealing with exponentials that have the same bases, but the question is today, how do we solve exponential equations with different bases? Okay. And one thing I want you to remember from the last test is that if I have a log of a negative number and a log of 0, these are two situations where the logs are undefined. The logarithms are undefined. So here's a set of steps that we want to follow. So let's look at step 1. Isolate the exponential term. So kind of similar to what we looked at a little while ago. The difference is in step 2, we're going to take the ln, the natural log, or the log of both sides of the equation. So you're going to take the natural log if you see that the exponential has a base of e. If it has other another base, then we're just going to do log of both sides. Step 3. Rewrite the log of the exponent using the power rule. Rewrite the log of the exponent using the power rule. And then isolate the variable. And then we're going to use a we're going to truncate the answer to the 10,000ths place. So I'm going to put a link on Blackboard, and that link's going to take you to a calculator that you can use. It's an online calculator, basically so we can type out log functions, because we're going to get answers in decimal places. Okay. So we're going to get an answer with logs, and we have to type them into the calculator. And what I want you guys to remember is, that when we're using the calculator, we're going to type in log base 10, because remember, if it doesn't have a base written next to it or underneath it, then we assume that it's a base 10. But again, I'm going to leave you guys a link on Blackboard that's a calculator where you can, it's a link to a calculator that you can input your answers in and get a decimal place. Okay? So let's look at example 7. Let's look at example 7. All right. So, step 1. Isolate the exponential term. So it's any term that has a base and an exponent. So if you notice here, it's by itself. Second step, take the natural log or the log, depending on what base you have, of both sides. So remember, if I have a base e, I'm going to do natural log, the ln. But if I have another base, in this case I have a base of 19, I'm going to use log. So what that means is we're going to write log of both sides. So it's going to look like this. We're going to do log of the left side equals log of the right side. Okay? Step 3, rewrite the log of the exponent using the power rule. Using the power rule. And so, if you remember about when we talked about logs as past test, we said that if we have an exponent, we can move it to the front of the log. So this is my exponent, so I'm going to move it to the front. So it's going to be x plus 3 times log of 19 equals log of 93. So this is that's the exponent, and I moved it to the front using the power rule, right? And so the next step is to isolate the variable. Isolate x, get x by itself. So what's happening between this parentheses and this log? What operation is happening? I'm kind of pointing to it, right? They're multiplying. So the opposite of multiplication is division. So what we're going to do is we're going to divide log of 19 on both sides. So this is going to cancel with this. And I'm going to be left with the parentheses, right? X plus 3 equals log 93 over log 19. And then one more step, or actually two more steps, but one more step to solve. What's the opposite of adding 3? Subtracting 3. subtracting 3. And so my answer is going to look like this. X equals log of 93 divided by log of 19 minus 3. Okay? So that's my answer, but what I want you to do is I want you to type it for me in the link that I provided you on Blackboard. Go to that calculator and type it out and see if you get the same answer. But make sure that you type it in with a log base of 10. And I'll fix that in example 8. But you should get a decimal answer of negative 1.4606. Negative 1.4606. Okay. So what I want to do now is zoom into example 8 and make sure we have enough space. And so let's see. All right, example 8. Isolate the exponential term. So this is 13 to the power of negative 9y minus 10. So this is my exponential term. It's by itself. So my next step would be to put log on both sides. So what I mean is, so let me write it this way so it can make a little bit more sense. Okay, so what I'm going to do is I'm going to copy. Let's copy the problem, right? So I copy the problem, and what we want to do to both sides is we want to take both sides and put a log on both sides. Okay, and then the reason we want to do that is because we can use the power rule for logs to bring down the exponent. Because where's the variable that we want to solve for, right? It's up here. So we want to be able to bring this exponent down, and the only way to do that is to use logs. And so let's take this exponent that I underlined, and let's move it to the front. It's going to be negative 9y minus 10 times log of 13 equals log 2. Alright, so kind of similar to what we did in number 7. What's the opposite of multiplying? Dividing. So we're going to divide both sides by log 13. So that's going to cancel this log of 13 and this log of 13. That's going to leave us with the parentheses, that's negative 9y minus 10 equals log of 2 over log of 13. Okay. And so we got to do, what's the opposite of subtracting 10, right? Adding 10. So I'm going to add 10 on both sides. It's going to cancel. And then let me bring down the negative 9y equals log 2 over log 13 plus 10. And then one last step to solve for y. The opposite of multiplying by negative 9 is dividing by negative 9. So these will cancel. And so I'm left with y equals, and again remember it's log base 10 of 2 over log base 10 of 13 plus 10 divided by negative 9. Okay. And so when we type this into our calculator, we're going to get a decimal, and you should get a negative 1.1411. And I want you to try that calculator out. Try it out. Type in the answer and check to see if you get the same decimal. And keep practicing it, because the calculator requires a skill, and we get better as we practice using it. So I want you guys to practice that. Okay. Let's go to the next example, example 9. Here we have an exponential term. It's a base e. So remember, we're going to use the natural log. But is the term by itself? Is the exponential term by itself? No, right? There's a 1, so we need to subtract 1 on both sides. So we get e to the 2m equals 47. Equals 47. And then step 2 says raise both sides to the log. But since it's a base of e, remember e uses natural log. It's ln. ln. So we're going to write ln on both sides. And again, the purpose of doing this is to make sure that we can use the power rule of the logs. So what I want to do is I want to move this 2m to the front. Move the 2m to the front. So it's going to be 2m times ln of e equals ln of 47. Okay. But what I want you to remember, that ln of e equals 1. ln of e equals 1. So this part here is equal to 1. So what's 2m times 1? What's 2m times 1? 2m. 2m. Right. One more step. Divide both sides by 2. Cancel. And I'm left with m equals ln 47 over 2. Again, I want you to try out the calculator. Type it in. Okay, and so if you type it in the calculator, your answer will be 1.9250. 1.9250. Okay. Example 10. isolate the exponential term. So we're going to add 10 on both sides, and that's going to leave us with e to the power of 7 minus 2n equals 71. Actually, let me leave some space here, equals 71. And then what we're going to do is we're going to do something to both sides. So I'm going to put both sides in parentheses, and I'm going to multiply, or I'm going to apply, take the natural log of both sides. Because we have a base of e, so we're going to use ln and ln. Okay, and so what we're going to do is we're going to take this power and move it to the front. It's going to be 7 minus 2n times ln of e equals ln 71. Remember, ln of e equals 1. ln of e equals 1. So that's going to leave me with 7 minus 2n times 1 is 7 minus 2n. And then bring down the ln of 71. Okay, so then next step is subtract 7 on both sides. It's going to cancel here. We're going to get negative 2n equals ln 71 minus 7. Then divide negative 2 on both sides. And so n equals this fraction. And again, type this fraction in the calculator, and you should get, actually I should have been using this, right? Approximately 1.3686. Approximately 1.3686. Okay, 2 more. You guys are doing awesome. Okay, isolate the exponential term. Isolate the exponential term. So this is the term I want to isolate. And so the opposite of adding 5 is subtracting 5. So that's going to leave me with 10k plus 5. These are going to cancel. Equals 103 minus 5. It's 98. Now, is this base an e? No, right? So then we're not going to use ln, we're going to use log. So we're going to put log of the left side and log of the right. Same idea, we're going to take this power and move it to the front. So it's going to be k plus 5 times log of 10 equals log of 98. And so one thing I want you to remember is that log, if it doesn't have a base written, we assume that the base is 10. And so log base 10 of 10 is equal to 1. So this expression that I boxed out, this is equal to 1. So what's k plus 5 times 1? k plus 5. So I'm going to be left with k plus 5 equals log of 98. And then one more step, right? We're going to subtract 5 on both sides. 5 minus 5 cancels. And so k is approximately negative 3.0087. So again, if you type this in the calculator, check to see if you get this decimal to make sure that you're typing it correctly. And remember, if it asks you to put a base, what's the base if it doesn't say? It's a 10. So remember, if you're typing this out and it asks you to put a base, the base is going to be 10. All right, one more. Awesome. Okay, so here, again, we want to isolate the exponential term. So it's going to be this term right here because it has a base and it has an exponent. It has a base and an exponent. Okay, so I need to get rid of the minus 7 and the times 4. So the opposite of subtraction is addition. So we're going to add 7 on both sides. It's going to cancel here. So we're going to be left with 4 times 3 to the v plus 5 equals 48. And then how do you get rid of the 4, right? What's the opposite of multiplying by 4? Dividing by 4. So 4 divided by 4 cancels. And so we have 3 to the v plus 5 equals, what's 48 divided by 4? It's 12. It's 12. Oh, actually, let me leave some space here, but it is 12. Okay, the next step, we're going to use log to both sides because, again, what's the base of this exponential? It has a base of 3, right? So we're going to use log. And so we're going to put a log in front of the left side and a log in front of the right side. And we're doing this so that we can make sure that we can take this exponent and move it to the front. So we're going to write v plus 5 in the front, and then log of base 3 equals log of 12. And similar to what we've been doing, what's the opposite of multiplying? Dividing. So we're going to divide log of 3 on both sides. So log of 3 and log of 3 will cancel. And we end up with v plus 5, we bring that down, equals log 12 over log of 3. Then we subtract 5 on both sides. This will cancel. And so v is approximately negative 2.7381. So again, what we want to type is, we want to type this fraction minus 5. We want to type log 12 over log 3 minus 5 in the calculator and see if we get this answer. So let me zoom out here. So I want to thank you guys again for joining me. And I hope again that you're staying safe and you're taking precautions, and you're there with your loved ones and taking care of them and making sure that they're safe. And I'll see you again later with another lesson. But again, I want to thank you for joining me today, and have a great rest of your day. Bye.